Okay, folks, welcome back. Section 7.4. We're talking about ellipses today, and I actually did a little bit of research between page 1 and page 2, and just so that we're all on the same page, that word right there is pronounced ellipse, and that word is pronounced ellipses. So the plural form is ellipses, the singular form is ellipse. Okay, now that we have that out of the way, let's go to page 2 of the notes. For page 2 of the notes, in question 2 here, we're asked to consider the following equation. And then in part A, we're asked, how is this different than equations from the first page? And the thing I notice is that both denominators are the same. So from here, what do we want to say? Well, how is this different than the first page? Well, we have A equals B. And that's a big difference from the first page, so I'm sure it's going to affect how the graph looks, which is what we're asked to think about in the second question. What do you think the graph of this equation looks like? Well, on page 1, we talked about the eccentricity of an ellipse. And we said the following: for an ellipse, eccentricity has to be between 0 and 1. So here's what I know about the eccentricity of an ellipse. As E gets bigger, and by bigger I mean closer to 1, the ellipse flattens. As E gets smaller, or closer to 0, the ellipse gets more circular. Okay, so what I'm going to do now is I'm going to jump down to part B of this problem, and in part B we're actually going to look at the equation that we were originally given and see if we can transform that equation into something else. The first thing I'm going to do is multiply both sides of the equation by 25. So if I have x plus 3 over 25, try that again, x plus 3 squared over 25 plus y plus 2 squared over 25, and that equals 1. If I multiply both sides of this equation by 25, I'm going to get the following. I'm going to get x plus 3 quantity squared plus y plus 2 quantity squared equals 25. And I know this is a circle with center of -3, -2, and radius of r equals 5. Okay, so let's circle back up here and say, what do you think, go back to part A where it says, what do you think the graph of this equation looks like? Well, it's kind of obvious now when we went through the algebra here in part B. It's a circle. And what connection I'd like you to be able to make now is that a circle is a special type of an ellipse. So a circle is an ellipse with E equal 0. Okay, so eccentricity is kind of a measure of how eccentric the ellipse is, how non-circular it is. If that non-circular measurement is 0, then it's a perfect circle. If that number E increases up towards 1, it becomes more elliptical, flat, like a flattened out circle. That's it for this problem. Let's see what we have now ready in question number 3. Okay, in the meantime, we're going to move down to here to question number 3. Question 3 is consider the equation given here, and then it is an ellipse. We're asked to put it in standard form and find the center, lines containing major and minor axes, the vertices, the foci, and the eccentricity. Okay, so let's start here by grouping terms together. So I'm going to start with x squared minus 2x plus, and notice I have a coefficient out in front of the y here of a 2. I'm going to factor that out. Notice that when I factor that out, this negative 12y becomes negative 6y because I have to distribute the 2. And I'm going to go ahead and move the constant term to the other side. Hopefully what you recognize here is I'm setting this up for completing the square. I'm not going to complete the square on both x and y. So for x, that's going to give me x squared minus 2x plus 1. And then for the y squared term, I'm going to have y squared minus 6y plus 9. And where did the 9 come from? I cut negative 6 in half to give me negative 3, squared it, and I got 9. Don't forget, we have to, whatever we do to the left-hand side of the equation, we also have to do to the right. So I need to add 1 to the right, and then I have to add 2 times 9, or 18, to the right. Okay, let's go ahead and factor these perfect square trinomials now. This is going to be x minus 1 quantity squared, and then I have plus 2 times quantity y minus 3 squared equals, let's see, it's going to be 18, 19 minus 3, which is 16. So I have now something that looks closer to the equation of ellipse, but not yet. What I have to do now is divide everything out by 16. So I'm going to, because this is kind of new, I'm going to go ahead and show you the algebra here. I'm going to divide everything out by 16. And let's rewrite what we have now. I have the quantity x minus 1 squared over 16 plus, well, 2 divided by 16 is the same as 1 divided by 8. So this becomes 1 minus 3 quantity squared divided by 8. And that equals 1. Hey, that looks a lot like the standard equation of an ellipse, and it sure is. Now all we have to do is describe all the features. And we'll go ahead and start with, let's see, the center. And that's easy enough. That's going to be at 1, 3. And then the lines containing the major and minor axes. So let's talk about that. If I look at this, I know I'm going to have a equals the square root of 16, which is 4. And b equals the square root of 8, which is 2 root 2. So a is greater than b, which means my horizontal axis, my major axis is going to be horizontal. So in order to find the equation or the line containing the major and minor axes, the major axis will be horizontal. And its equation will be y equals 3. Horizontal will be y equals a number, so it's going to go through the center, which has a y coordinate of 3. And the minor axes will be x equals 1. Okay, so we've taken care of that. Now we need to find the vertices. So the vertices, we're going to think about this for a second. The vertices are going to lie on the major axis, so on y equals 3. So they're going to have a y coordinate of 3. I can go ahead and fill that in right now. And how are we going to find the x coordinate? Well, we're going to take this a value and we're going to adjust our x coordinate. So I'm first going to subtract 4 from 1. That will give me negative 3, 3 as the vertice on the left. And then I have to add 4 to 1. 5, 3 will be the vertice on the right. Okay, so let's talk about the foci now. Well, in order to talk about the foci and where they're located, I need to find the value of c. And let's remember that c equals the square root of the big denominator divided by the small denominator. So that's going to be the square root of 16 minus 8, which just equals the square root of 8, which is the same as 2 root 2. because that's going to get in the way of my list, I'm going to move this information up here. Hopefully you're okay with that. Oh boy, that all got divided up. That's an issue. Okay, so my vertices, we've already figured those out. Now I'm back into talking about my foci. So for my foci, I need to adjust, again, I'm going to adjust the x-coordinate along the major axes. So my y-coordinate will stay the same. And this time I need to adjust the number 1 left by c units. So that's going to be 1 minus 2 root 2. Y-coordinate is still 3. And then I need to adjust my center to the right by c units. And again, those aren't nice numbers. I mean, they're exact numbers, but they're not real nice because it's hard to think about what 2 root 2 looks like. But trust me, those are what those are the locations of the foci. Okay, so what do we have next here? We have the eccentricity of the ellipse. And for eccentricity, it's distance from center to foci divided by distance from center to vertex. In this case, that's going to be the value of A, because the horizontal or the major axis is horizontal. And let's see, C is 2 root 2, and my A value is 4, so that simplifies to root 2 over 2. And I think that's it, folks. We've captured all the information we've been asked there, and it is all contained right here in this nice little bulleted list. It's all the features of this parabola. Okay, let's move on to example question number 4. Number 4, find an equation for the ellipse with foci at 0, comma, plus or minus 5, and vertices at 0, comma, plus or minus 8. So for this problem, might make sense just to do a quick sketch. So let's go ahead and let's see what's going on here. So I'm going to quickly sketch an x and y axes. And let's go ahead and mark some points on this graph. I'm going to have, I'm going to call this 0, comma 5. I'm going to call this 0, comma negative 5. And those are the locations of my foci. We'll call that F1 and F2. And then I have vertices at 0, comma 8. And 0, comma negative 8. And, well, what would that ellipse look like? Well, clearly the foci and the vertices lie on the line that is the major axis. So it's going to be, what can we determine from this? We know the major axis is vertical. It's actually going to be x equals 0. Let's see what else we know. Well, let me just go ahead and sketch an ellipse through these points. It's going to look something like that. Oh, that's not. You deserve better, folks. We got to do better than that. So let me try that again. I'm going to go down, see if I can do better. That's a little bit better. Hopefully you can get by with that. So distance from center to vertex is the B value. So we know B equals 8. And we know distance from center to focus is the C value. So we also have C equals 5. And I already mentioned this, it kind of goes without saying, but the center is at 0, comma 0. So that's all the information we can get just from the given information. From here, though, we can calculate the value of A. So if we use C and B, we know that C is going to equal the square root of b squared minus a squared. Why b squared minus a squared? Because it's bigger denominator minus smaller denominator. Since this ellipse is vertical, we're going to have a b value that's larger than a. So let's plug in what we know. We know c is 5, and then we know b is 8. So 8 squared is 64. We're going to subtract a squared there. When I square both sides, I'm going to get 25 equals 64 minus a squared. I'm going to move some things around, do some algebra, and find out that a squared equals 39. So from this point, I think we really have all we need to write the equation of this ellipse. I'm going to need to know my b value and my a value. So remember, our equation is going to look like this. X minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Let's fill in what we know. H and k are both 0. So my numerators are just going to be x squared and y squared. A squared is 39. And let's see, b is 8, so b squared is 64. That's it, folks. That's the equation of the ellipse that has vertices at 0, plus or minus 8, and foci at 0, plus or minus 5. All right, folks, almost done here. One last example. Let's see if we can persevere through this one. So let's start. Find an equation for the ellipse with foci at plus or minus root 5, 0, and an eccentricity of 1/2. Okay, so first let's look at this. What kind of information can we get just from the fact that we know where the foci are located at? Well, I'm going to go ahead and list everything that tells us. First of all, it tells us that the major axis is horizontal. And the reason why it tells me that is because the x-coordinate is changing. So along the line y equals 0, we have negative root 5, 0 and positive root 5, 0 for the foci. It also tells me that the value of c, the distance from center to foci, is root 5, because I know that right in the center of those 2 points, I'm going to be able to locate the center, and that's going to be at 0, 0. So heck, we're halfway home, folks. The only thing we have to do is come up with a and b, and we've got our equation. So let's see how we're going to do that. First thing we're going to do is we're going to use eccentricity E to solve for a. Now I know that eccentricity for a horizontal ellipse, eccentricity equals c, distance from center to foci, divided by a, distance from center to vertex. So we know our eccentricity is 1/2. We know our c value is root 5. So now we have this equation. This looks like a lot like a proportion. We ought to be able to solve that for a. A equals 2 root 5. Or a squared equals 20. And I hope you can do that without a calculator. I hope you can square 2 root 5 and get 20 without a calculator. Okay, folks, let's move on here. I'm going to go ahead and number the second step here. Second step is we're going to use C and A to find B. Okay, so remember we have this relationship. C equals the square root of the bigger denominator minus the smaller denominator. Well, we know our ellipse has a horizontal orientation, so this is going to be a squared minus b squared under here. So we have a value of c. That's root 5. and we have a value for a squared, that's 20. So we have to solve this equation for b. Actually, we don't even need b, we'll just solve for b squared. I'm going to square both sides. That gives me 5 equals 20 minus b squared, or b squared equals 15. So I'm ready to rock and roll here. I've got this, and this. Those are the only things I need to write the equation of this ellipse. And remember, that takes the form x minus h squared over a squared plus y minus k squared over b squared equals 1. And I'm writing that. You might be thinking, wow, that's pretty repetitious of him to keep writing that formula. I figure if I write it a couple extra times, maybe you'll remember it in the future. So we have h comma k is 0, 0, so both numerators are going to be x squared and y squared. My a squared term is 20. My b squared term is 15, and this all has to add up to 1. There you go, folks. The final answer to the final example problem in the notes for section 7.4, ellipses.